Hi guys, and welcome to this video about rationalizing the denominator. In this video we're going to build off what we covered in the previous video about surds, and we're going to look to simplify fractions where we have surds on the bottom. To begin with, I'll just break down the technique and explain the reasoning behind what we're doing. Let's start with a very simple example, so just a single fraction with one number on top and one number on the bottom. And we can see that on the bottom of this fraction we have square root of 7. Now, having fractions with a surd on the bottom is not a usual way of writing it. We'd much prefer the surds to be on top because it just means the fraction is easier to work with. One property of surds is that if we multiply a surd by the same surd, we just get whatever is inside the surd. Of course, squaring the square root of 7 is going to just give you 7. So let's bear that fact in mind. What we're going to do is multiply the fraction by the same number top and bottom. In doing so, this is equivalent to multiplying the fraction by 1. We know that we can't multiply the fraction by anything else, otherwise that would just change its value. So combining these two facts, we can see that we need to multiply our initial fraction by the square root of 7 over the square root of 7. This is going to satisfy both of these conditions, where not only do we rationalize the bottom, we rationalize the denominator of the initial fraction by having root 7 times root 7, but also we're not multiplying by any other number than 1, as we have the same number over the same number. Remembering that when we multiply fractions together, we do the top line times the top line and the bottom line times the bottom line. On the top, we can just leave that as 14 root 7, remembering that that is how we write 14 multiplied by root 7. And on the denominator, I know that root 7 times root 7 is just the number inside the root, which of course is 7. The last step when you're doing these questions where we're rationalizing the denominator is to make sure you've simplified your fraction as much as possible. Because we have 14 on the top and 7 on the bottom, we can see that these numbers share a common factor of 7. Cancel out 7 top and bottom, leaving me with the answer of simply 2 times root 7. Let's use that technique and look at this first example. The last question we multiplied by simply the number 1, however we wrote it as the same surd over the same surd. The surd that we chose was in order to rationalize the denominator of the fraction. In this case, the denominator is the square root of 5. So the fraction I'm going to need to multiply by is of course going to be the square root of 5 divided by the square root of 5. This is going to satisfy both of those initial conditions. For the top line of this fraction now, I will need to multiply in this square root of 5 to the bracket as such, and of course the bottom is the same surd multiplied by the same surd, so we can just write that as 5. The top line then will look like root 5 times root 5, which again is 5, and then doing the root 5 multiplied by 5 will leave me with a 5 root 5. Finally, the last step is simplification, and we can see that there is a common factor of 5 in the terms on top and the bottom. Remember, when we're simplifying fractions, we have to divide the entire line on top and the entire line on the bottom by the same number. So doing that, we will end up with just 1 plus root 5. Let's look at a second example here, where I have 1 plus root 2 over root 2. I'm going to multiply this fraction by the square root of 2 over the square root of 2, and hopefully you spotted that, as that is a multiplication by 1, and it will also rationalize the denominator. So working this out, on the top line I will have the square root of 2 multiplied by the bracket 1 plus root 2, and on the base of that fraction I have root 2 times root 2, which just gives me the 2 inside the surd. Multiplying out the top then, I have the square root of 2 plus root 2 times root 2, which is just 2, and moving the denominator over, I have still 2 on the bottom. This fraction here can't be simplified any further, as there's no common factor between all of the terms top and bottom. Next, we're going to investigate how to rationalize the denominator when we don't just have a single surd. We might have an expression where we have an integer plus or minus a surd. In order to know how to do this, we need to understand the difference of two squares. If you haven't seen this before, I'll do a quick explanation now. When we have a plus b multiplied by a minus b, the expansion of this will be a squared plus ba minus ba minus b squared. Now if we take a look at the middle two terms, we will see that plus BA and minus BA will cancel out with each other, leaving us with just the first term squared minus the second term squared. Let's try that where one of those numbers is a constant integer and the other number is a surd. So we'll look at 1 plus root 2 multiplied by 1 minus root 2. Remember, our goal of these questions is to rationalize the denominator, so we don't want any irrational numbers, which in this case are surds, to be inside of the denominator when we've finished. We only want rational numbers to remain. So again, doing our expansion, we're first going to do 1 times 1, we're then going to do the 1 times the minus root 2, then the 1 times the positive root 2, and finally root 2 times minus root 2. So 1 times 1 is 1, root 2 times 1 is plus root 2, minus root 2 times 1 is minus root 2, and finally the positive root 2 times the negative root 2 is going to give us minus 2. So if you don't quite understand where the minus 2 came from, just ignore the signs, do the root 2 times root 2, and then remember that plus minus gives us a minus. So we can see here that the central two terms, much like before, are going to cancel out with each other, leaving us with just 1 minus 2, which of course is just minus 1. So we went from brackets containing irrational numbers with the two root 2's to finally just having a rational number remain. Let's combine this information that we've just found and the idea of multiplying our fraction by the number 1. This means that we have to have the numerator the same as the denominator. We've seen that for the bracket 1 plus root 2, we require 1 minus root 2 in order to rationalize the denominator. This means on the top, I will need the same expression. On the top then, I'll have 1 multiplied by 1 minus root 2, so that's just 1 minus root 2. And on the bottom, I've already done this multiplication of 1 plus root 2 multiplied by 1 minus root 2. We can see the only difference between these two brackets is that we've changed the sign in the middle. That will of course give me 1 minus root 2 over minus 1. We can now combine that minus 1 into the fraction, so we would have minus 1 plus the square root of 2. Let's look to generalize this idea. When we have the expression 1 over a plus or minus our square root of b, we're going to need to multiply by the same expression top and bottom on this fraction, and we're going to flip the sign between the rational number and the surd. So for the plus case, it will be minus, and for the minus case, it will be plus. So this is the general rule that we must use when we're looking to rationalize a denominator. Let's take a look at these two examples together. For the first question, we see that the denominator is 6 minus root 3. We know that in order to rationalize that denominator, we need to flip the sign in the center. Therefore, the denominator of my fraction equivalent to 1 has to be 6 plus the square root of 3. The numerator has to be the same in order to keep that fraction equal to 1. Let's expand out this multiplication. So we've got 22 brackets 6 plus root 3, and on the bottom we're going to have the 6 times a 6, so 36. Remember that the central two terms will cancel, and finally we're going to be doing minus root 3 times plus root 3. So the root 3 times root 3 will give me 3, and then the minus plus will give me a minus. So that will be minus 3. Let's expand out the top. That is 132 plus 22 root 3, and on the bottom we'll be left with 33. The final step is to simplify this fraction. We can see that there is a common factor of 11 on the top and the bottom. This will leave us with 12 plus 2 root 3 all over 3. For this second example, we can see that the base has two surds. However, the same ideas apply. We can just change the sign in between those surds and write that as the denominator of our new fraction. So we will have root 5 minus root 3. Of course, the numerator must be the same as the denominator. On the top line, I will then have 10 brackets root 5 minus root 3. On the denominator, I will have root 5 times root 5, which is 5. And once again, the central two terms will cancel. I will be doing root 3 times root 5, which I can just write as root 3 root 5. And I will have on the outside minus root 5 times minus root 3, which is just minus root 3 root 5. Of course, those terms have the same size, but different signs, so we'll cancel each other out. Finally, I'll have plus root 3 times minus root 3, which of course is just minus 3. So on top, I'll have 10 root 5 minus 10 root 3, and the denominator will just be 2. I can now simplify this because there is a factor of 2 on the top and the bottom, leaving me with this expression here. Let's look at this final example together. It looks quite a complicated expression, but there's some things that we can spot that will make it easier for us. For starters, we can see that on top we have the idea of the difference of two squares. We have a bracket with a minus sign in it, the same bracket, followed with a plus sign in it. So we know that when we spot these two brackets next to each other, they're going to rationalize. Let's multiply out the top. The 4 times the 4 will give me 16, then minus 4 root 2, then of course plus 4 root 2, and finally minus 2, with the minus root 2 times the root 2. Let's just ignore the denominator for now. Simplifying the top, I have 16 minus 2, which is just 14. And of course, the 4 root 2 and the minus 4 root 2 will cancel. Now we have the case where we have an irrational denominator, but we know what to multiply the bottom by. It is just the same expression with the sign flipped. Keeping the numerator the same, we can now multiply out these two fractions. On top, I'll have 14 root 11 plus 14 root 7. And on the bottom, I'll have 11 minus 7, remembering that the central two terms have cancelled. Now on the bottom, I can do 11 minus 7, which is 4, and simplify by cancelling a 2 top and bottom. And that would leave me with 7 root 11 plus 7 root 7, all over 2. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.